Here I'm going to discuss IPv6 access control lists. In a previous video, I talked about the functionality of access control lists in general, and I talked about the configuration and verification of IPv4 ACLs. Here we're going to look at how IPv6 ACLs are similar or the same, and yet how they're different from IPv4 access control lists. Their functionality is still the same. So we'll go through that, and we'll do a configuration example, and that's it. So there, as I said a moment ago, the function of an IPv6 ACL is the same as an IPv4 ACL. The only difference is that it works on an IPv6 network. And I'll do one example of an IPv6 network only, and then I'll do one of a mixed protocol IPv4, IPv6 network. One of the ways they're different is that IPv6 ACLs have no concept of a standard access control list. There's no quote-unquote standard and extended ACL. It's basically a named. It's similar to an extended named ACL. You cannot do numbered IPv6 access control lists. IPv6 ACLs use prefix length instead of a wildcard mask, so we don't configure a wildcard mask. Instead, we configure prefix length. And they have, along with the implicit deny all that IPv4 ACLs also have, IPv6 ACLs have the implicit deny all and two implicit permits, a permit ICMP NE ND-NS and ND-A. Those are used for neighbor discovery. So they're neighbor discovery solicitation messages and advertisement messages that are needed in IPv6. It's kind of like the equivalent to IPv4 ARP. And those are there by default. You won't see them in the running config, but you do need to be aware of them, that these are needed in your network, in your IPv6 network, and they are part of the ICMP protocol suite. So just something to pay attention to. So it has three implicit statements for IPv6 ACLs, and that's the deny and our two permit statements. So here's our first IPv6 example. And I took the same information, so if you watch the IPv4 video, this will look really familiar. The topology is the same, and the requirements are the same. The only difference is that I'm using an IPv6 network rather than an IPv4 network. So here what we're going to do is we're going to allow only PC 1 and 2 to get to the web of SRV, right? So that's our www, port 80. These guys here, we're going to allow them to go there. PC 1 can't go to any PCs inside of branch 2. So we're going to stop PC 1, from going to any PCs. Right now we only have one, but we're going to specify it as a whole network, as this whole LAN, because it's little, it's our example network. It's a little unrealistic to only have one PC, right? And then PC2 can send files to the PCs on branch. So PC2 basically can communicate with those PCs. In order to do that, we write an access control list, IPv6 access-list, give it a name. In my IPv4 video, the name was host to SRV. So in this one, I just added v6 because you cannot have an IPv4 and an IPv6 access list named the same thing. But since they could be just mirrors of each other, right, we're trying to control the same things on the IPv6 portion of our network as we are on the IPv4. So if they're mirrors of each other, then I may want to name them the same. And one way to separate the names would just be to add, either v6 for version 6 or v4 for version 4. Then we get into our statements. So we start now we're in our sub configuration. Permit TCP host 2104:1:10. That's PC 1, right? To go to host 2103:1:10 EQ 80. So it says you're allowed to go to the web of this guy, 2103:1:10. I'm going to get rid of, when I start getting too much pen, I want to get rid of it and start again. And now we have to then, so we've allowed PC1 through, let's allow PC2 through. Permit TCP host 2104:1:12, which specifies our PC2, to again go to 2103:1:10 equal to 80. So again, the web of SRV. We want to deny IP host 2104:1:10. This is PC1. We're going to deny him going to everything within this LAN, which will then not allow it to go into any PCs inside of branch 2. And then we want to permit we want to permit PC2 to go there. Permit IP host 2104:1:12, 2105, going to this LAN, 2105:1:/64. And again, just notice we use a prefix length instead. I could have also done, if I knew that my files I was sending was through FTP, I could have done like an EQ FTP, correct? So that's one thing we could do. Let's go ahead and get rid of our ink again. The other thing we can do is just something to be aware of, and I can do this in version 4 and in version 6, and I don't think I discussed it in the version 4 video, and it's just something that came to my mind. You don't have to use equal all the time, EQ for equal. You could use greater than, or GT for greater than, LT for less than. So if I wanted to do everything 80 and above, include 80, all the ports 80 and above, I could have done, instead of doing equal to 80, I could do greater than 79. Or if I wanted to do all ports 80 and below, I could do less than 81. So everything less than 81 would be 80, 79, so on. So you can do more than just equal to. You can do greater than, you can do less than, you can do other things. This is just what I did to specify specifically those ports. So now we've configured our access entries right here, and this comprises our whole list. Now we need to apply to the interface. Here's one way IPv6 is also different from IPv4, and that's in the way that we apply it to our interfaces. We use the command IPv6 traffic filter and then the name. So IPv6 traffic filter, the name of my ACL, and then the direction, in or out. And again, this time, because these are the guys that I'm kind of filtering and working with, their flow is going in to branch 1 gig 02. So it's always from the perspective of the router in the flow of the traffic. Okay. This interface isn't always in. If I was trying to deal with server and he was only allowed to go certain places, then the flow of the traffic goes this way. And if I'm still configuring branch 1, which in this case I probably wouldn't be, I suppose I could be, but I would go closest to the source, which means I'd configure it here. But if for some reason I configured it down here, or you have different, then the flow of the traffic would be coming from the perspective of the router, would be coming in there. But in this case, it's coming in here. So we're going to get rid of that. So not too bad. I mean, it's really very, very similar to IPv4, except for I'm using IPv6 addresses. And I've got, the commands are slightly different. I use IPv6 here. I use traffic filter here. And I use a prefix list rather than a wildcard mask. One other thing, when we're applying them to, if I want to apply my access list to the VTY lines, I want to control Telnet or SSH, I would still use access class for both IPv4 and IPv6. So when I apply it to the VTY lines, I really need to get a pen instead of using my mouse to do this. Whoops, that's not what I wanted to do. Hold on, sorry. When I apply it to the VTY lines, I would be using access class command. And I would do that for IPv4 and IPv6. So this is just when you apply it to the regular interfaces, that IPv6 uses traffic filter rather than access group. So let's go ahead and look at this configuration on a dual IPv4, IPv6 network. I'm going to take the configuration I had before from the previous video of IPv4. We're going to verify that, in fact, my IPv4 access list doesn't control what's going to happen in my IPv6 network. And then we're going to add mirroring IPv6 ACLs so that I can accomplish the same thing I originally wanted to accomplish on both IPv4 and IPv6. So let's go ahead and look at that. So we'll switch to, this is our topology. This was the topology we used in the previous video for IPv4. All my IPv4 addresses are in red. My IPv6 addresses are in blue. The routing of the whole thing, the connectivity, is totally configured. It's working. And I have left the ACLs on there for IPv4. So we can see IPv4 and IPv6 working together. So with IPv6, what we did is basically the same, with IPv4, we basically did the same thing that we're going to do here, is that we took all hosts. It was on this network here, right? So when I had my bullet point here before, it said all hosts on the 10.10.1.0 network can go to the web of SRV. Now this time, now we're looking at the IPv6 portion of this network. So now all hosts are allowed to go to 2104, or on 2104:1:: are still allowed. So it doesn't matter if I use IPv6 or IPv4 on these hosts. they're still going to be able to get to the web of this server. And then we're going to permit, or we're going to allow PC1 to ping and telnet to branch 2. So maybe this guy is the administrator for branch 2. I don't know. I just have to give you some examples here, so that was one of them. All right, so I brought the window over for my PC1. Remember, he's sitting off of branch 1. In our IPv4 access list, and what we're going to do with our IPv6, but with our IPv4 access list, we allowed him to go to the web of the server, or SRV, which was 172.18.1.10, and we allowed him to ping and telnet to branch 2. So if we go ahead and verify that he can go to the web, and he can. Now, if you remember, what this actually is not a PC running a web server, 172.1.10. It's actually a router with IP routing disabled and the HTTP service enabled. So if I get this prompt, it means that I've gotten in through web. Now I just have to give it a username and password, which I didn't configure. So the web is working great. Now what I didn't allow it to do is it can only get to the web of the server. So it can't ping the server. Whoops. Oh, sorry. And it still cannot ping the server. That's my access list is doing what it's supposed to be doing. But here's the interesting thing, and here's what I keep talking about when I say if we have an IPv6 and IPv4 network, likely if I wanted to restrict access from IPv4, I probably wanted to restrict it from IPv6 as well. But if I ping the IPv6 address of that server, it's successful. So now in this video, what we want to do is we want to go ahead and configure IPv6 ACL that mirrors the requirements that we had for our IPv4 setup. So we'll go ahead and do that. And I'm just going to go back here and just remind us what it is we wanted to do. We're going to allow these hosts in here to go to the web of SRV, and we're going to allow PC1 only to ping and telnet to branch 2. These are the commands we're going to use. So the next thing I'm going to do is I'm just going to pull over our branch 1. All the configuration will happen on branch 1, right? Because we want to start closest to the source of our traffic. So I'll bring over my console or my telnet connection for branch 1. All right, so I've pulled that over. Let's go ahead and configure our IPv6 access control list. So in global config, if we do IPv6 access, -list, and then give it a name. Here I'm just going to give it a name of hosts. And now we can start with our statements. First thing we want to do is permit our hosts inside 2104 to go to the web /64. Because I wanted to do all of the hosts, and we would just make the assumption that we'd have more than 2 PCs, right? Then what I did is did everything on that LAN. So everything on this LAN, the source is 2104:1::, it's a 64-bit prefix length, going to the IPv6 version or address on the web, or on our SRV, sorry, :1::10. Did I get that? Equal to web. Whoops. All right. Now our next one is to allow ICMP and telnet to branch 1 from PC1. ICP host 2104:1:10. Now we don't need a prefix list because we use the keyword host, or I'm sorry, a prefix length because we use the keyword host instead. Going to 2102, :1:1. This here is the IP address of the Ethernet interface on branch 2. And we're going to allow it to echo request. And last one, permit TCP host, again, PCA. Oops, sorry, get my mouse out of the way. And this time we're going to go equal to telnet. Remember, we have our implicit deny all at the end, plus our 2 implicit permits for our neighbor discovery. And we need to apply it to the interface now. We want to apply it to the closest interface, so gig 02, and we use the traffic filter command. We spell it correctly. hosts. And the flow of the traffic is coming into the router. So hopefully that's good. We'll go over to PC1 now and see if we can still ping SRV. Bad thing about live demos is things go wrong. So let's see. So we're sitting back in our PC1, and if I hit the up arrow, oh, live demo that worked. Remember before we had our ACL we could ping, now we can't, which is what we're not supposed to be able to do. Let's verify though that we can still get to the web, like for some reason we didn't just lose connectivity if we messed up our ACL or something. It's a little bit different how you have to type an IPv6 list in. We're going to put it in brackets. So our address is 2103 for the server, or SRV, :10. Whoops, hold on, I got to put an end bracket in there. Sorry about that. Oh. And we were able to get there. So we're able to do what we need to do. We could also go back and just make sure we can ping to branch. We can. Let's telnet. :1, right? Look at that. So our access list is doing what it's supposed to be doing. We could double check it with PC2. So I brought the window over for PC2. And we should be able to go to the server of PC. I'm sorry, we should be able to go to the web of SRB, but we should not be able to ping it, and we shouldn't be able to ping branch. So let's go to branch because that's what we allowed PC1 to do. Let's just make sure that in fact now PC2 can't do it as well. 2102 :1 : whoops, sorry, :1 : 1, correct? Yes. And we can't ping it, so that's good. Now let's see if we can go to the web, which we should be able to, the web of SRV. So 2103 :1 : 10, and we can. So we have been successful in configuring IPv4 and IPv6 ACLs. That is it.